Let's welcome Ada.
Hello, everyone. I'm Ada. I'm an 18-year-old from India, and in October, I was sponsored by Shell to attend their annual conference in Bangalore. There, I got the opportunity to interview the CTO of Shell and talk to a bunch of executives about their AI projects in energy. And I realized I was very passionate about building scalable platforms using AI. After the conference, I researched how AI can be used to solve supply chain problems at Shell. Currently, oil and gas supply chains have two main challenges: volatile costs and labor and material shortage. Both these challenges can be solved by minimizing supplier risk, because essentially a supply chain is made up of suppliers. If you're a machinery supplier for Shell for their rigs or refineries, a supplier risk is any factor that may negatively impact your ability to deliver the goods on time. And often this can have ripple effects throughout the supply chain. If Shell is successfully able to minimize supplier risk, they can save up to 15% of costs. This amounts to $6.2 billion for Shell annually. The problem is that the current supplier risk management systems are too narrow in terms of their risk assessment. So they only depend on internal logistics data, and they fail to take a holistic assessment of market risks, such as legal risk, geopolitical risk, and even potential mergers. They also have limited visibility into hidden risk and interconnections between suppliers, and supply chain disruptions are not reflected promptly in the internal data. So, to tackle these problems, I've designed an AI powered supplier risk management platform. Supply chains that use AI are 67% more efficient than traditional ones. And now let's look at the tech behind it. So, I'm using two machine learning approaches. The first is natural language processing. So, through NLP, we can take public unstructured data, such as social media posts, news articles, which are updated in real time, and combine it with external and internal databases to perform a wide range of analysis and categorize risk into various categories like ESG, legal, and climate risk. This can help broaden the number of risks we measure, increasing visibility. The second model I use is graph neural networks. So they're very useful in predicting relationships and are actually better than traditional machine learning approaches to find systemic risks, such as financial fraud detection. So we can represent all the suppliers in our supply chain as nodes, and GNNs can help predict hidden risks such as potential merger signals, which are actually the most common cause of supply chain disruption. So let's look through the features of the platform. For Shell, I designed it to be built on top of their existing supply chain platforms, so it leverages existing data structures. On the dashboard, we can visualize suppliers on the basis of risk. The core feature of the platform is the supplier analysis. So we can conduct an internal and external supplier risk analysis based on the data. We can also customize the risk assessment based on the company's priorities. Then we can get an overall risk score and measure its trends, and then also understand how various suppliers are connected based on their risk levels. And finally, take action to mitigate risk for each supplier. The risk analysis is fed into the recommendation tool, and you can use the chatbot to generate strategies for optimizing certain cases. Such as I can ask, like, how can I minimize supplier risk in Bangalore? And it can give me a bunch of strategies. You can also review the supply chain related decisions made by other departments to improve coordination. The recommendation system is based on the Optimus architecture published at Stanford recently, and this uses large language models to formulate optimization problems and also generate the code for modeling this. The most challenging aspects of designing this platform was making sure that the models work well together behind the platform. To tackle this problem, I am continuously getting more and more feedback from the machine learning engineers. I'm also iterating on the user experience of this platform and coordinating with Shell's digital partners to explore how this tool could be potentially integrated into their workflows, and also exploring a potential internship with Streamba, which is an AI supply chain startup. Thank you so much for listening to my presentation, and I'm very happy to answer any questions.
Thanks,
I have a question, actually two questions. The first is, a lot of what you're saying with respect to the problem that you're solving for Shell I'm wondering how transferable that is to other industries, right? So in oil and gas, the things that you're supplying from supplier 1 to supplier 2 to supplier 3, they're more predictable, let's say, than maybe a textile in a textile factory. So as you think through transferring what you've developed in the context of oil and gas to other industries, what are some of the big challenges that you're thinking through?
Yes, thank you. That's a great question. So, the core structure of the platform is transferable because essentially we're using both the internal data available based on in the company databases, based on the logistics data, and also using external public data. So combining that can give us like a more holistic picture of our supply chain, and this can be transferred to other industries. The reason I started and developed this model for Shell was because of the conference, I did have a lot of practical understanding of their challenges. That's why I went first and like try to tailor it to their current problems. But this is transferable as because of their simplicity, because there are only like a couple of machine learning models being used at the moment.
Got it. And the second question is, it's around unstructured data. So one of the core challenges with predicting supply chains is you have things that happen at suppliers, right? Machines break. We're seeing right now with respect to like shipping turmoil, political instability. And so my question is, like, what role should AI and machine learning play in helping predict things like tariff regulations or political instability or shipping lane blockages? What role do you think AI can play, and what are some of the main challenges with ingesting that data?
Right. So, uh, if we're talking about predicting risks, there's like we can apply machine learning in like more broader market risks, such as like geopolitical risk and like you mentioned, tariffs. The the main structure, the main challenge comes with the data preparation, the scoping, and but I have been talking to many experts, and actively work is being done on like creating more structured ontologies and making sure that the data is we can fasten up that process. And for like in terms of machine learning, the another reason why Shell was a great starting point for developing this platform is because they already have a lot of digitalization strategies being implemented, such as like digital twin across their oil rigs and refineries. So that gives us even more further data points about like what's happening in each of our rigs and refineries. And if a machinery has not been supplied, it's not been delivered, then we can add that into our database, and that can even add more data points. So I think to tackle the challenges that come with predicting risks efficiently through machine learning is through understanding holistically how can we digitalize a lot of the data that we have in these more traditional industries like energy, oil and gas, and which is what Shell is currently working on. And I think that's why they're a great place to firstly implement this platform, because it cannot work in isolation. It needs to work in an ecosystem of digital technologies being working together and transferring data.
Thanks.
Thanks, Ada. Thanks, Brandon, for the question.